All right, folks, let's simplify this monster. I don't think I'm offending anyone when I say that. This is a monster. And I'm not joking with you. This is not a joke. You do see expressions like these in calculus. This expression is obtained by applying the quotient rule for differentiation, finding derivatives, to this expression here. A fairly basic algebraic expression. So you do see things like this in calculus, and you may be called upon to simplify these things. I'm not kidding. Now, there are many ways that you can attack this problem, but the key thing is to show work along the way and understand that your friend may come up with a different solution from yourself. All right. So we start here. And we might want to begin by cleaning up the numerator. Because what I have here is what you get when you apply the quotient rule for differentiation directly. Okay, now first off, let's see what we have on the top here in the numerator. How many terms do we have on top? We have one term over here, this times this, and then we have this big second term over here. All right. When you see primary plus or minus signs, that indicates the start of a new term. Of course, there's an implied plus sign out here, right? But we have one term over here, and then this minus sign starts a big second term up here in the numerator. -1 times x squared times 1/3 times this power here times the 4. This is all one big ugly term in the numerator. So we have two terms up on top, which means that we should not be doing any top-bottom sort of canceling or dividing just yet. So for example, many people are going to try to do something with this over here and this over here, these powers of 4x plus 7, but don't divide them out yet. Not yet, because we have two terms on the top. Okay, now let's start by cleaning up the numerator. Now in this first term on top, well, we might want to put the 2x in the front on the left. We often like to put the polynomial pieces on the left. That's not necessary, but visually it might be helpful. For the second term on top, what is the coefficient here? We have a -1 factor. Okay. I'll put this in blue. We have a -1 factor. Right? We have a 1/3 factor in here. And we have a 4 factor in here. What is -1 times 1/3 times 4, or 4 over 1? That might be easier for you. When you multiply this together, you get -4 over 3, -4/3. That's the coefficient of the second term in the top, -4/3. Now, do not move any of these pieces over to the first term. That's a very common mistake. Imagine a big river here, okay? Don't cross the river too easily. So don't move the 4 over here. Don't move the 1/3 over there. Okay, don't pull stunts like that. All right, so what do we have? Equals, don't forget the equal signs. Okay, we're indicating equivalence. We have the big fraction bar. The denominator stays the same. Okay, so this is no problem. 4x plus 7 all to the 2/3. On the top, the 2x we'll put on the left side. We have the power, 4x plus 7, all to the 1/3. If you're afraid that you're going to confuse the 1/3 as an exponent for 2x, you might actually prefer this. So it's up to you. But I'll put the 2x, the polynomial piece, on the left. That is conventional. And then for the second term in the top, we have the coefficient, the -4/3, and then the polynomial x squared, and then the power, 4x plus 7 to the -2/3. So I'm cleaning up the numerator. I'm making it look nicer. And that's part of the battle right there. And from this point, there are two major strategies that we can pursue. In method 1, we're going to factor the top. We're going to factor the numerator, including these weird powers of 4x plus 7. We've done this kind of thing before in section 0.8. So let's factor the numerator. And we're going to ask ourselves, well, what's the GCF of the top? Okay, so again, let's take a look at the terms here. We have one term over here and the second term over here in the top. So what can we factor out of both? You could say that we can factor a 2 out of both, although the 4/3 here is a fraction, so that's a little weird, but you could factor a 2 out of both, so that could count as part of a GCF, potentially. All right, x versus x squared. Put this in purple. X versus x squared. Which do we factor out? The power of x with the least exponent, x to the first. We can factor out an x. In green, we can call 4x plus 7 u eventually, do a u substitution. U to the 1/3 versus u to the negative 2/3. Which do we factor out? The power of u with the least exponent, that's going to be u to the negative 2/3. So u, if you do the substitution, or the quantity 4x plus 7, that common base, 4x plus 7, all to the negative 2/3, or u to the negative 2/3. So you could argue that either this or this could be the GCF of the top, the greatest common factor of the top. Actually, the 2 I'll ignore for now. So I'll ignore the 2 issue for now, right? And as for these guys, actually, it may be difficult to walk and chew gum at the same time. I cannot blame students at all if they wanted to if they wanted to factor out the x first and then factor out this power of u later on, or vice versa. In fact, as it turns out, we may not even have to factor out the x. But we are going to have to factor out this weird power here. Notice the 4x plus 7 here. We have a power of 4x plus 7 in the bottom. I think we're going to have to manipulate this guy. So at the very, very least, I think we're going to have to factor out u, or 4x plus 7, to the negative 2/3 out of the top. Maybe factor out an x also. Maybe factor out a 2 also. But at the very least, we're going to have to factor out this thing out. Okay, let's do it. Let's factor the top. Okay, and while we're at it, I'm going to do a u substitution. So 4x plus 7 equals u. 4x plus 7 equals u. I'll type that out. It's good to indicate what the substitution is. Let u equal the quantity 4x plus 7. You should state that. All right. Now in purple here, okay, I apply the substitution. So you're probably going to want to follow this purple column here. All right. So I apply the substitution before I do any factoring. I apply the substitution. We get, well, okay, we get 2x u to the 1/3 minus 4/3 x squared u to the negative 2/3 all over u to the 2/3. So I apply the substitution and I get this over here. Okay. That required some patience. Don't miswrite things. Often mistranscriptions are the cause of key errors. Just not writing things right. Okay, now, again, you could factor out a 2, but let's not do that right now. Factoring out an x, we may or may not have to do that. Let's go ahead and do that. Let's factor out an x. Let's be ambitious. Let's also factor out the appropriate power of u. Again, we have u to the 1/3 here. We have u to the negative 2/3 here. We would factor out u to the negative 2/3. All right. So here I'm being ambitious. I'm factoring out both the x and the u to the negative 2/3 out of the top. I could not blame you at all if you thought this was too much. It may be too much to walk and chew gum at the same time. So you might want to factor these out bit by bit. As I note previously in my notes, it may be easier to factor out the GCF piece by piece, maybe the x in one step and this power of u in another step. The GCF does not have to be factored out in one step. As it turns out, we may not even have to factor out the x. All right, but let's try to factor, and again, we have u to the 2/3 in the bottom, all right? So this is good, u to the 2/3 in the bottom. All right, now on the top, when we factor out the x, when we factor, we do what? D-word, we divide. We divide this by x, the x disappears. We divide this term by x, the x squared goes to just a plain old x. All right. So this times what will give me the 2xu to the 1/3 up in the upper left. All right. So who's missing? Who's missing? Who's missing? When we factor out this, what's missing from here that I need to put in here? Well, the 2's missing. 2xu to the 1/3 divided by this. Well, 2 divided by 1 is 2. So the 2 I have to put in here. The 2's missing here, so I need the 2 in here. All right, x divided by x, that leaves a 1 in here, times 1, but we don't have to indicate that. X divided by x, there's no x in here. Now, u to the 1/3 divided by u to the negative 2/3. When we factor, we divide. When we divide powers of u, what do we do with the exponents? We subtract them. We started with u to the we started with u to the 1/3, right? We take away negative 2/3, the exponent out here. So we started with 1/3, we take away negative 2/3. When we divide powers of u, we subtract the exponents. So u to the 1/3 minus negative 2/3. What is that, by the way? And then minus, we carry over the minus sign, all right? The 4/3, well, he wasn't out here. I need him in here. 4/3 divided by 1 is 4/3, all right? X squared divided by x is x once again. X squared divided by x is x. Again, you could do this in a later step. U to the negative 2/3 divided by itself is 1. So we don't need a u guy out here. In fact, don't put a u power out here. All right, over u to the 2/3. So we factored out xu to the negative 2/3. When we factor, we divide. We see who's left. Okay, after we divide these two terms by this, who's left inside the brackets? All right. What's 1/3 plus 2/3? That's 3/3 or 1, which we don't even have to worry about. U to the first is u. Okay, so we copy this, xu to the negative 2/3. That's not a problem. We copy the 2. Again, u to the 1/3 plus 2/3. That's u to the first. That ends up being plain old u. U to the first is u. And then copy the negative 4/3 x. This all goes over u to the 2/3. So the only thing I did here was that I indicated that 1/3 minus negative 2/3 end up being 1, and we can delete that exponent. If 1's the exponent, we don't need it. Okay, look what we have here. We actually do have one term over one term, which means we can now do top, bottom, canceling, or dividing. We have one term over one term. Remember, one of the key purposes of factoring is to get everything into one term. So over here, we had two terms, but because we factored the top, we now have one term consisting of these three factors. We have one ugly term with three factors: the x, the power of u, and this thing in brackets. So we can now do top, bottom, canceling, or dividing. In particular, I'm looking at the u to the negative 2/3 and the u to the 2/3. U to the negative 2/3 is a factor of the entire numerator. U to the 2/3 is a factor of the entire denominator. It is the entire denominator, so we can now divide. And what do we get when we divide u to the negative 2/3 by u to the 2/3? I'll give you 20 seconds to think about it. Oh, and the answer is not 1. You can't just go bye-bye and the answer is 1. No, no, no. The quotient is not 1. These are not twins. Now, if we had a u to the positive 2/3 up here, yeah, you could just go boom and you get 1 as the quotient of these guys. But no, that's a u to the negative 2/3 up here. These are not twins. So it's not quite that easy. It's not too bad, though. All right. So what's happening? We have u to the negative 2/3 divided by u to the positive 2/3. When you divide powers of u, you subtract the exponents. So we get u to the negative 2/3 minus 2/3. What is negative 2/3 minus 2/3? It's negative 4/3. So we have u to the negative 4/3. And if you wish, you could put that in the top and erase the bottom. But what does it mean to multiply something by u to the negative 4/3? Well, how can we write u to the negative 4/3? As the fraction 1 over u to the positive 4/3. Now think of this as being this over 1. This hops down as a factor as u to the positive 4/3. Which means when you multiply by u to the negative 4/3, you're really dividing by u to the positive 4/3. The u to the 4/3 goes in as a factor of the denominator. U was, when you sub back, 4x plus 7. So you end up with 1 over u to the 4/3 as the quotient of these guys, and that subs back to 1 over 4x plus 7 all to the 4/3. All right. We may not be ready, or we could be ready to sub back. Yeah, we could be ready to sub back at this point, actually. All right. So what's happening? All right. I'll erase all this. Although that was the key factor, dividing these powers of u. Key issue. Okay, we have the x here. That goes over here. U to the negative 2/3 divided by u to the 2/3. We end up with u to the 4/3 in the bottom. Okay. Or 4x plus 7 all to the 4/3. Remember, that was our substitution. Remember, u was 4x plus 7. U was the quantity 4x plus 7. All right. So we end up with u to the 4/3 in the bottom, this u guy to the 4/3 in the bottom. All right, that's from here. That was all this work here. Inside the brackets, we have the 2. U becomes, I'll do this in green, u becomes the quantity 4x plus 7, do put parentheses, or some grouping symbols. The minus here, 4/3 x minus 4/3 x, that's over here, that's copied. So after you perform this division with the powers of u and you sub back, you end up with this over here. Looks like a missile strike. This over here. Can I divide with these guys? No, because the 4x plus 7 is too deeply embedded in there. Okay, we have 2 terms inside the brackets. It's a mess. However, 2 times the quantity 4x plus 7, we can distribute. That's natural, all right? So 2 times 4x is 8x, 2 times 7 is 14. Not a problem. So now we're up to here, equals x times the quantity, 8x plus 14 minus 4/3 x, all over 4x plus 7 to the 4/3 exponent. But now, we have another problem. We don't like fractions inside fractions. Now, the 4/3 exponent here may be unavoidable in the end, really. But this minus 4/3 x inside the brackets, we can take care of this. We can take care of this thing so that there's no little 3 in the top. And how can we do that? We can multiply by 1 creatively. So how can we multiply by 1 in such a way that we get rid of the 3 eventually? If we multiply by what over what? How about 3 over 3? Again, we're multiplying by 1. That's always legal. So what we're going to do is we're going to multiply the top and bottom by 3. Compound fractions or complex fractions, that's when you have fractions like these inside a fraction, are typically unacceptable in a simplified expression. Sometimes fractions in an exponent, like 4/3, are acceptable. Okay, so we multiply the numerator and denominator by 3. I indicate that over here, the 3 over here, the 3 over here. That makes this a bit clearer. Okay, and then we can distribute the 3 into here, here, and here. Multiplication distributes over addition and subtraction. Powers or exponents don't, but constant multipliers do. Multipliers do. All right, so 3 times 8x is 24x. 3 times 14 is 42. 3 times this thing, negative 4/3 times x, I'll write that as x over 1, times 3, I'll write that as 3 over 1. Well, those 3 factors divide out, and you get negative 4x left. Basically, the 3 here ends up killing the 3 there. But as it stands, don't just go boom, boom like that, because then you might forget to distribute into here and here. So it's very dangerous to strike these. Okay, do side work. Maybe do this part here as side work. All right, so we have, and also I'm multiplying the x also. So we have 24x squared, x times x is x squared, plus 3x times 14 is 42x, minus 3x times 4/3 x is going to be 4x squared. So if you wanted to be a bit more ambitious and multiply in the 3x, right? And actually, maybe that's a bad idea, actually. That's one reason why I just multiplied in the 3. In my work here, I multiplied in 3x, but it turns out that you might want to factor out the x anyway. So here, I multiply in 3x, but that might be overkill. But if you multiply in 3x, you get 24x squared plus 3x times 14 is 42x, and then 3x times negative 4/3 x is negative 4x squared. So you have negative 4x squared over here. Over. Now, can we distribute the 3 here through the 4x plus 7? The answer is no. The 4/3 here prevents that. Now, if that were a 1, or if you saw no exponent up there, you could, and you'd get 12x plus 21 in the bottom. But because you have an exponent here, you're not allowed to distribute easily. Okay, again, do not distribute the 3 in the denominator. The 4/3 exponent forbids that. On the top, we can combine like terms. 24x squared minus 4x squared is 20x squared. We carry over the plus 42x. And it turns out that this will be an acceptable answer. However, we want to make sure that it's simplified. So look, you may want to factor this back to make sure it's simplified. Okay, we should factor the numerator back and see if there are any common factors between the numerator and the denominator, besides plus or minus 1. Those are trivial. If you have any non-trivial factors, any common factors besides plus or minus 1, they have to be canceled or divided out. So here on the top, we may want to factor 20x squared plus 42x back anyway. The GCF is 2x. 20x squared divided by 2x is 10x. 42x divided by 2x is 21. Okay, and actually, many books would prefer this form, because then, because the top and the bottom are in factored forms, then you see more clearly that we have a simplified form. It's clearer to see that this is simplified. Now, the expression on the left also turns out to be simplified, but it's not as clear. It's not as clear that this left expression is simplified. Here it's clearer. And also, how do you know when you're simplified? How do we know there's not a 3 factor up here? There's not. If we had a 21x squared up here, we would. But There's no 3 factor up here. We don't get a power of 4x plus 7 up there. If you look at this, you might be able to tell you're simplified, but it helps to factor the top and the bottom to make sure. The bottom's already factored. So again, back here, that's why I multiplied in the 3 to get rid of the 3 of this bottom denominator. But actually multiplying 3x might be too much. You might just want to multiply in the 3 and keep the x out here. Eventually, you can factor out the 2. Again, many roads can lead to Rome. You might do it one way. Your friend might do it another way. As long as you show your work, okay, convince a competent colleague. Don't just go, oh, I'm so smart, I did it all in my head, okay? Don't do that. You have to show steps. Convince me that you can convince a competent colleague, all right? You have to show things step by step. Although your steps could be different, and they could be in a different order. You can adjust your strategy and strategize in different orders. In the end, I would accept either as a final answer, although here on the right, it's clear that this guy's simplified. Wow, that was one way to simplify this big old monster up here. We're going to see a second method in just a moment. We'll start just after we've cleaned up.